do here is use HclustHeatmap to make a heat map. And this is a complex command, so in a Unix shell window, you can use a backslash to separate a command onto multiple lines so we can look at it more easily. And that's what I've done here. And I sort of preloaded this command ready to hit enter. So HclustHeatmap is the program that we use, and this is downloadable separately from the rest of the Metaflan package. So you have to get it, deliberately get it on your own along with Metaflan if you're going to try to use this particular way to display heat maps. There are other ways that we'll show you in the other parts of the tutorial. So my input -I is the stream abundance table genus.txt that we just made. My output is the stream abundance heat map genus PNG file that we have not yet made. And the distance measure that I'm going to use here is Bray-Curtis distance. There are multiple options for this that we could choose, but that's sort of a typical one. And then there's these file, sort of the visual settings for the heat map. And we're really going to have to optimize these by trial and error because we don't know exactly there's not one size fits all recipe for what character sizes to use here because your heat map is going to be different from situation to situation. So let's just look at what this produces. Okay. So I have, there's some errors that come through here that don't really make a difference to whether we can do this or not. And then I'm going to have this stream abundance heat map genus.png that we just created, and that's right here in my Finder. So on an Apple, I can just double click this. So as you see, these names are not optimal yet. They're a little bit too big. The heat map cell ratio that is set there isn't really being applied because there's just too many genus level classifications here. So what we can do is we can tinker around a little bit. Let's go with the 50 seems to work for the label length. The label size is a little bit too big. Let's try 2. This is going to be small text, and this is the trade-off is between having your text fit and be able to look at it and not having it be too small to read easily when you just have this many classifications. So try again and pull up the new version of that heat map. And now the file name, the size, the classification names are manageable. They're not overlapping each other. You can see what's there, but this is really kind of a big heat map. And what you might end up doing with this is you might end up filtering down so that if you have only 0 values on a row in your in your data table, you might just exclude them, or you might exclude them if they were only present in a very small number of reads, which is something that is a little bit more complex to do. So you could sub-select this data now based on what you see here and maybe choose not to display these rows where you really have almost nothing present because that complicates the visualization of your heat map. But we've gotten to something sort of acceptable here, and we can see that our samples from the different locations, and let me zoom in on this. So our samples from the different locations in our analysis tend to cluster together. So we have our residential sites are clustering together, our upstream sites are clustering together, our downstream sites are clustering together, and our aeration tank sites are clustering together. And that really is what you hope for and expect when you have replicates of samples. You don't want them to behave in a way that is different from each other. And we can see that in the dendrogram as well. So the downstream sites and the aeration tank effluent sites, which are related to each other, are actually coming out closest together. And the residential sewage is its own whole thing here, isolated from everything else that's influent. And then the upstream site is isolated somewhat from these other the other samples as well, because that is the stream prior to any introduction of treated wastewater. So that makes sense from that perspective. So that's what we get if we make a simple heat map out of this data that we've collected for the stream microbiome project.